Welcome to Team B's demo of our PHER application. Team B consists of Iris Perry, our team leader, Anthony McAlpin, myself, Austin Hoelscher, and Isaac Nevarez-Saenz. We understand that health is one of the most important factors in everybody's day-to-day life throughout the world. We also understand how difficult it can be for patients to understand factors that can affect their health. Many patients are dependent on medical institutions to store their medical records for them. And the record-keeping systems can be very different between institutions, and it can be very problemsome when patients want to go to different providers or need to go to specialists and need to have that information shared between providers. To solve this, we are proposing a mobile application, Personal Health Electronic Record, PHER for short, that allows patients to track and share their own health records between providers and medical settings. Throughout our research, we identified two types of users, patients and medical providers. Two patients, Paul and Patrick, had issues with managing their healthcare records. They were tasked with combining large amounts of health information when visiting different institutions. They had no access to their own personal data, and they ended up paying large administration fees just to get the information passed between one provider and another. And it was unfortunate that they had to pay all these extra and unnecessary fees just to get information that they should have had to begin with. We're attempting to reduce these costs and make it a lot easier for patients to share this information to benefit them. The second type of user we identified was healthcare providers. Two members of a healthcare team, Polina and Patricia, had a lot of issues sharing information with each other for their patients. These institutions stored patient data separately and had no good way to share them safely and securely. Providers at these new institutions where their patients come don't always get the information from their previous institution. We identified functional, non-functional, and user interface system requirements. Our functional requirements include our CRUD operations for medical records, or create, read, update, and delete operations for activities, appointments, and medications for the user. Our system will be able to send notifications directly to the user of upcoming appointments. Our system will also be able to generate statistics for users' physical activity and sleep. Users will securely be able to log in safely and be able to also share health data with their providers. Our non-functional requirements included private storage of user data, the ability to handle requests from multiple users simultaneously, a quick response, especially for recent records, for patients to be able to review their health data accurately. And our user interface allows users to have very easy access to all of our CRUD functions, and users will also be able to choose a role, whether they're a patient or a provider. To develop our program, we're utilizing the MySQL database. For our backend, we're using Node.js and Express. For our front-end development, we're using HTML5, CSS with Bootstrap 5, Vanilla.js, and a full calendar API for our users' appointments. To write our code, we're using VS Code. For collaboration and version control, we are using GitHub. And for our testing, we are using vTest. Now I will turn it over and we will discuss our front-end development.
I will now demonstrate how to create a new user. First, go to the login page and press sign up. We're going to create demo user 1 for the username. First name is going to be demo. Last name is going to be user. This is going to be for a patient. The email is going to be demouser1@pher.com. And then we'll create a password. We get a message. Now I'm going to use the information that I So that I just used, that I just created, and log in. And now we have access to our homepage. In this video, I will show how to add a medication to the patient record. We'll have to click on the medications tab. As you can see, this patient has no medications on the record. We're going to go ahead and add our first medication, which started on February 1st of this year. And patient stopped taking it on the 1st of March. This medication was prescribed by Daniel Smith. The medication name is Maxide. Patient was taking 1 tablet. These were 25 milligrams each. We're taking it once daily. And the patient was experiencing muscle cramps. I'm gonna go ahead and press submit. We get an alert, and then we can see here that the medication has been added. Now I will demonstrate how to delete and edit a record. As you can see here, there are duplicate records for the medication Pepsid. So we'll go ahead and press delete. And it turns out that the patient had additional side effects that they want to record for Maxide. On top of the muscle cramps, they also had drowsiness. They just couldn't figure it out until later, so they have to come back, fix the record.
Hi, so I'm going to go ahead and do a dry run for adding, editing, and deleting in activity. So here's our add activity form, and we can go ahead and start by filling in the date, which you can either type in, or if you click the calendar, you get a drop-down menu. So we'll say we did this today. Then currently we have activity length, and we specify in minutes. So we can say this activity took about 45 minutes. We can say we went on a hike. And then from there, we will submit. We get a pop-up that says the activity was added successfully. And we should see it populate in this list right here. So now let's say we realize the activity actually took us 50 minutes or something like that. We can actually go ahead and increase that, and you can type it in or increment it like this. Save changes. We should get a pop-up that it was a success. And again, we can see that change right here. Then when we want to go ahead and delete that, we can just hit the delete button. And we'll get a pop-up asking us to confirm that we do want to delete this activity. And we'll go ahead and hit OK. Activity deleted successfully. All right, and then again, we should no longer see it on this list. All right.
Hello, my name is Iris Perry, and I will be demonstrating the appointments portions of our personal health electronic record application, and I will also be demonstrating the testing portion. For the appointments portion, users first must log into our application. After logging into our application, they can navigate to the Appointments tab. Over on the right, there is a form for users to add appointments. They will first input the appointment date, then the title of the medical provider that they are going to see, the name of this provider, the purpose of their visit, the phone number of the provider, and if applicable, their email. After they submit this form, the data will be sent to the database. Over on the left, we have a calendar that is populated with these appointments that the users add. we use the full calendar API to implement this calendar. If the user clicks on one of their appointments, a modal will pop up with the appointment details. In this modal, they can then edit the appointment, or they can delete the appointment. The full calendar API also supports a list feature to list these appointments out. That concludes the appointment portion of this demonstration. For the testing portion, we used a bottom-up approach to testing. We implemented tests for each one of our CRUD functions. As far as integration testing, none of our classes really interact with each other. So we did not implement any integration testing so far. We use the VITEST testing framework to implement these tests. This is the add activity test for our addActivity.js file. How this works is it mocks the local storage to simulate a logged in user. Then it mocks fetch to simulate a successful response from the server. And then it sets up a basic HTML form with fields for the date, the activity duration, and the comments. It then fills in the form fields with this test data, and then it simulates a submission by dispatching a submit event on the form to trigger the form submission logic, which prevents the default action and then sends a post request with the form data. It then verifies and checks if the fetch was called with the correct URL and ensures that the body request matches the form data. The test ensures that when the form is submitted, it sends the correct data to the server via a post request. All of our tests are implemented similarly to this. With the VITEST framework, it is very simple to run these tests. First, you must start the server using node-mon-server.js, and then create another terminal and run the tests with npmt. After running the tests, it will tell you if the test passed or not. That concludes the testing portion of this demonstration. Thank you.
Hi, my name is Austin, and I'm going to be talking about the code for our backend API and the technologies we used to build it. For our database, we are using an instance of MySQL hosted on an AWS server. And for the actual API, we built it using JavaScript along with the Node.js runtime environment and the Express framework. So our API is split into three major components. We have routes, controllers, and services. For routing requests through our application, we took advantage of Express's routing functionality. We have all of our base routes located in the server.js file here. Then, according to the API endpoint, it is routed to the appropriate file for either activities, appointments, medications, or users. Those files are found here. Then these files then further route the request to the associated controller method based on the corresponding HTTP method. Okay. Within the controller methods, we do server-side validations and data manipulation if needed. This is also where we call the associated method within the corresponding service file. So for instance, in the addActivity function, we would call on the service file right here. Okay. The service files where we have direct interaction with the MySQL database utilizing parameterized, right here, parameterized SQL queries. These parameterized SQL queries help to ensure correct formatting of parameter values and also help to protect against attacks like SQL injection. This direct interaction is done using a connection string, which is right here. And this connection string is configured using values pulled from a .env file. And that does it for our backend.
Some of the challenges our team has faced while developing this application has been time management. We're all full-time students and full-time employees at our jobs, so it can be hard to find the time to dedicate to such a detailed project. With that being said, we do make sure that we dedicate any time that we have to this project to make sure we have a successful project and application to deploy. Version control and contributions by our team members has been another issue we've ran into. And with that, it's really just making sure we're on top of what anybody else has done. That way, we're not doing the same thing or messing up anyone else's work. With that being said, communication on a daily basis is how we solve all of these problems. This allows us to let everybody know what we've done so far and allow us to keep in touch and know what's going on with our application. We've postponed some of our work to demo 2, and that'll be our notifications to the user, statistics for the user's activity, a provider login, and allowing our users to share records with their providers. That being said, our PHER application is designed to help patients track their health data instead of depending on their healthcare institutions. This application will improve communication between patients and providers and also save patients time and money and get them more efficient healthcare because our providers won't be tied up in the paperwork side of things with their records. Currently, our users are able to add and delete records and also have a safe, secure login and sign up.